Let's do exercise 25 on page 50. This is in section 2.2. Exercise 25 says to find an explicit solution for the given IVP, initial value problem. So the differential equation is this one here, x squared dy dx equals to y minus xy, where y of -1 is -1. Okay. Well, we want to do this by separation of variables. So what we're going to do here is to isolate the derivative dy dx, and then we can divide both sides by x squared. So this would be y minus xy divided by x squared. And then we need to try to write this expression here as a product of a function of y or a function of x times the function of y. And this can be easily done. In this case, we can factor y here, and then this would be 1 minus x divided by x squared. So now you can see that this is your function of y, and this is your function of x, your g of x. Okay, so the solution of the ODE would be h of y equals to capital G of x plus a constant, where big H of y, that's the antiderivative of 1 over hy. Okay, so this is antiderivative of 1 over hy dy, and capital G, that's the antiderivative of g of x, and plus a constant. Okay, so let's substitute the functions in there. So this would be antiderivative of 1 over y dy. On the other side is the antiderivative. We can find the antiderivative separate and then put those in there later. But since these integrals will be easy, we can do it all together. So antiderivative of 1 minus x over x squared dx, and then plus a constant. Okay, on this side, the antiderivative of 1 over y dy, with respect to y, that's natural log of absolute value of y. And on this side, if you want, you can work this out a little bit more, simplify it a little bit more. You can write it as x -2 minus x -1, right? You divide 1 over x squared, that's x to the -2, minus x over x squared, that's x to the -1 dx plus c. So I didn't find the antiderivative yet, but now, so this would be x to the -1 over -1 minus antiderivative of x to the -1, that's natural log of x plus c. Okay, so let's rewrite this here. Natural log of y, absolute value of y, equals to, so this is -1 over x, -1 over x minus natural log of x plus c. Now we have some restrictions for this solution. As you can see, x cannot be 0 here, so we have to be careful here. There's just some little restrictions there. As you can see, x can be 0. Also, even more than x being not being 0, x can be negative. Well, actually, x can, right? This is absolute value of x. X shouldn't be 0 in the natural log here. So that's one condition. The other condition is the y value, the y variable, cannot be 0. So inside a natural log, you can't have negative numbers. But since this is an absolute value expression, so it's okay for x and y to be negative because the absolute value makes it positive. Okay, so that's the solution. Now, notice that it's an IVP, initial value problem, so we need to satisfy the initial condition there, which is this one here. So y -1 equals -1. So to satisfy that, so let me write it here. So that means when x is -1, y is -1 as well. So let me write this here. And x equals to -1, y equals to negative 1. So if we plug those numbers in, this is natural log of negative 1 equals to 1 over negative 1 minus natural log of negative 1 plus c. Okay, so this is 0, this is 1, this is 0 plus c. So therefore, c has to be equals to negative 1. So that's the implicit solution. Natural log absolute value of y. Let's go ahead and move everything to the other side here. Plus natural log of x plus 1 over x plus 1 equals to 0. Okay? So that's the solution of the ODE. Now we can write this as an explicit solution. It looks like we can, because here, see, the natural log plus another natural log, we can actually combine them. So this solution here is okay. You could stop here, but if we can get an explicit solution, then that's better. In fact, the exercise really asks you to find an explicit solution. So let's go ahead and try to solve for y here, which is not that hard. So you can see here that these two logs, I can combine them into one. So this would be natural log of x, y. Okay. So natural log of, when you add two natural logs, you can combine them, multiplying the expressions inside a natural log. So this is combining these two. Let me erase this line that I drew here. There you go. So I can combine these two. I guess we can move this back to the other side, like that. Now, so how do we solve for x, y? Well, if I have natural log of something, right? Natural log of a equals to b, well, this really means that e raised to b equals to a. Okay, so I can actually write x, y equals to e raised to negative 1 minus 1 over x. So my y here is e negative 1 minus 1 over x divided by x. Okay. Okay.